Hello everyone, good evening and welcome to Line Follower Hackathon. Let's begin. So let's see what all we'll be covering in this hackathon. So in this hackathon, you'll get to build your own autonomous robot. We'll guide you at each and every step, and by the end of the session, we'll ensure that each and every one of you has your autonomous bot running. And in this session, we need a few of the concepts which we learned in Craig 201. So we'll be recapping those concepts and letting you know how to make the circuit for the line follower bot and how the circuit works. So, and at the end of the session, we'll also be having a live demonstration here from Technology Robotix Society's lab at Technology Students Gymkhana. So, and we'll be able to clear all your doubts live using the components which we have over here. And this is a hackathon, so it's a very interactive session. So it's very much encouraged to each and every one of you to ask doubts and even turn on your cameras if you want and show us what you're doing so that it will be easier for us to clarify your doubts. And if you have any doubts at any other point, just feel free to interrupt and we'll just clear your doubts. Let's proceed. So what is line following? In a general sense, a line follower bot need not be just a bot that follows a black line on a white sheet. It can follow any particular line, like let's say a magnetic field, or maybe some other kind of environment that simulates a line. So the basic objective of a line follower bot is to, design an algorithm that makes it possible to follow the line without less number of deviations and all those kinds of things. So let's see how we are going to design the bot and uh, other intricacies which it has. And a line follower bot in general has a lot of applications, like it's a key aspect in industrial automation. So in industry, you'll need many kinds of robots which follow a line, because if you want to automate something, like there'll be some, you can just, line following is a, good thing in automation, like, and that's a very effective way of locomotion for a bot. So, uh, and it has many other applications. Let's proceed. So now let's look at the required components which we need. Many of you might be having freshers kit already. Can I get a hand raise on how many of you are having a freshers kit right now? Or other components? Need not be just a freshers kit. If you have the components, you'll be able to do it. Okay, nice. Around 31 people. That's good. So let me just go through the components and let's see each and every one of them. So these are the list of components which we'll be using: an IC7805 voltage regulator, a motor driver, and all these components we actually saw in Craig 201, so you might already be having a rough idea of how it works. But anyway, we'll go through few of the important components and how do they work, and ask you people to share any doubts which you have later. Okay. And of course, if you are not registered for Freshers Kit, register it for it soon, because ask your friends how important a Freshers Kit is. Like, what are all the components in it? Those components are very versatile. Like, you can make many kinds of robotic projects using it. So just explore it once. Let's proceed now. So now let's get a recap of the theory which we learned in Craig 201. as we all know, any robotic project or any robotic application has three kinds of elements: a sensor, a controller, and an actuator. So, can any one of you tell me like what can be the sensors, controller, and actuator in a line follower based on the components which we showed? Any idea?
IR sensor can be a sensor, and Arduino is the controller, I think, and the actuators are like motors which responds.
Okay, okay. So the thing is, IR sensor is the sensor. Yeah, that's good. But the thing is, we are not using an Arduino in this project. Okay. And the third thing is right. The actuator is the motor. So like the sensor is the thing that senses to this external environment and gives you the right output. For example, we'll see how an IR sensor works. Like for particular kind of input which you give, it will give you a particular kind of output. We'll explore how an IR sensor works in a short while. And of course, an actuator is a thing that gives an output in form of a mechanical or some other kind of output that changes the environment around the ball. So in our case, the actuator in our case is the motor, so that's correct. And the controller, you can assume the L29 3D motor driver which you are using kind of acts as an controller, and we'll see how it works. So these three are the basic things. The sensor is the IR sensor, controller is L29 3D, and actuator is a motor. Okay, so I guess everyone is in the same page. If you have any doubts at this point, you can ask. Okay, I guess everyone's in the same page. Let's proceed. So now let's see how an IR sensor works. So as you might be knowing from Craig 201 that an infrared sensor basically is a very popular and device which is used to detect obstacles. So this is how it looks. There are two LEDs. One is an infrared. There is one LED. This is an infrared LED, and the other is a photodiode. It's an IR receiver, and this is the IR transmitter. And this is a block diagram representation of it. Like when the transmitter transmits it, if there is an obstacle, it will reflect the IR radiation, and the IR receiver receives it. So the basic working of IR sensor is as follows. Like whenever an IR sensor receives a signal, so its output gets low, and depending on the configuration potentiometer. So the thing is, there's a potentiometer over here. This is what is called a potentiometer. It has a screw. This can be turned, but for now, I'll like tell you just don't turn it now. We basically use this turning things for debugging. We'll see it later what that is. And so this is a basic working. Now let me ask you a question. If we show white color to a working IR sensor, it output. Any idea?
Low,
More light will be reflected.
low,
Low, right? Yeah. Can one of you explain why low?
because white surface will reflect every infrared radiation that will fall on it.
Yeah, exactly. So a white surface, whenever you show a white surface to this, uh, white surface will basically reflect all the IR radiation which is incident on it, right? So whenever the IR receiver receives it, it will give you a low. And what about a black surface? When you show a black surface over here, what will be the output? Anyone?
It would be high.
Yeah, it would be high. So from this you can see that IR sensor is basically detecting, right? If so from that you can give that particular data which you get from IR sensor to a controller and do further processing. So now let's for a brief moment let's get out of this presentation and let me show you a small demo of it using the components which we have over here. Yeah, can we have the webcam please? Yeah, so this is the IR sensor which we have. I guess it's rotated, I guess. I mean, can you rotate it? Is it clear? None of you confirm. It's clear, right?
Yes, it's clear.
Yes.
Yeah. So the basic circuit which we have over here is an IR sensor. We have connected it. Okay. We have connected it to 3 pins over here, and we have taken those outputs from here. Like we have basically taken a 5 volts from Arduino. So we have connected it to the high and low columns of the breadboard. And for the IR sensor, we have given, I mean, it has 3 pins, right? One will be VCC, which should be 5 volt. One will be ground, and other one is the output. So those are the 2 pins. These 2 pins are for power and ground, and they are connected to the power and ground of Arduino. Okay. Okay. Let's just power the Arduino now. Yeah. Yeah, as you can see, the IR sensor is turned on. Basically, IR sensor has 2 LEDs which you can use to debug. So let's see now. If I show my hand like this, okay, it's not in the center, I guess. Yeah. Yeah, cool. So if I show my hand to it, what's happening? It's basically detecting the IR sensor, and the LED is turned on. Okay, the LED on the IR sensor. And if I just take my hand out, there's no IR radiation, so it's turned off. Now let's see what the output is using a multimeter. So you can see the reading over here. Okay. I just connect it to the 2 pins of. Yeah, I'll just connect it to the output. Okay. So can I have a black chart paper and a white chart paper? Yeah. So basically, when you show a black chart paper, it's showing a high of 4 volt. Let's see now the white chart paper. A little below. Yeah. So it's showing 0. That means a low, right? So we'll use these concept to design our board. So let's proceed. So in our path, we'll be having a white background on which we'll be having a black line. Okay. So if you have a black line on a white chart paper, we'll use the data which the IR sensor outputs, and accordingly we'll do the circuit. I mean, we'll make the circuit connections in such a way that yeah, how thick it will be. Yeah, we'll tell you how thick it should be for proper working of the board. Yeah. And we'll see how this data which you get from the IR sensor is used to control the motor. Okay. Okay, let's proceed. So this is the internal circuitry of the IR sensor. Currently, we will be not covering this. You can read about it on the net and understand how it outputs a high when it sees black and outputs a low when it sees white. Okay. And the other thing which we'll be using now is an L293D motor driver. Right. Let's see how that works and various pins it has and how to make the connections. So whenever you see an L293D, you'll see there's a small notch over here and a circle over here, which will identify the numbering which is over here. Right? Otherwise, it will create confusion, right? You'll not be able to see which pin is what. So that's the motive of this dot. So let's see. So we have first of all VCC1 and VCC2. VCC1 should be connected to what? Can anyone of you tell me?
So 5 volts of Arduino.
So this should be connected to 5 volt. What about VCC2? What's the function?
The 9 volt battery.
Okay, why 9 volt? Any reason? I mean, you can connect the 5 volt over here, right? Why particularly 9 volt? Any reason for that? Okay, let me explain. So, basic function of VCC2 is that whatever you connect at VCC2, the same voltage will be output at the output terminals. So, that's the function of an motor driver, right? Why do you need a motor? Because you cannot power a motor using a 5 volt or a short power supply which you get. I mean, small voltages cannot be used to power motors because they'll need a lot of current, and by the time you draw that much current, this voltage will drop and there's no use. So that's why we need this. The L293Ds. Okay, so there's an limit of what you can give for VCC2. Check out the data sheet of L293D. So that's the function of VCC2. Next, enable 1, 2 and enable 3, 4. Anyone?
So two pins of the Arduino which will be defined as variables in the program.
Okay.
It will activate the points, means the enable 1 and 2 pin will be used to activate the input 1 and 2 points, and enable 3, 4 will activate the 3 and 4
exactly.
points.
So if you want to use this side of the L293D, you need to enable 1 and 2. If you want to use this side, input 4, input 3, output 4, output 3, you need to enable 3 and 4. Currently, in this experiment, we'll be using both sides because it will be easier to connect two motors there on the both sides. So we'll be using both of these. So these two should also be high to 5 volts. Okay. And everyone might be knowing what to do with the ground pins. They should be connected to the ground. Next. So what is the function? How does an L293D work? Let's say, let me ask you a question. So we have connected VCC1 to 5 volts, VCC to 9 volts. Okay, VCC1 to 5 volts, VCC2 to 9 volts, and we have enabled enable 1 and 2. So if I give a 5 volts at output 1 and 0 at output 2, what will be output 1 and output 2? And we have grounded all these pins. So if output 1 is high, so input 1 is high, input 2 is low, what will be output 1 and output 2?
9 volts. Output 1 would be high and output 2 would be to ground.
What will be the voltage? Anyone?
9 and 0.
Yeah, exactly. So whatever you connect at this point, that will be the voltage at that output. Okay, output 1 will be at 9 volts and output 2 will be 0. Fine. If you have understood that much, then you'll easily understand what the circuit will be made later. At this point, any doubts? Feel free to ask. Okay. Because when you start building the board, you should not be confused about this.
Can you explain the outputs?
Okay, so the thing is, first of all, in order to use this side, you need to enable, and then the basic, it's very basic. Like if you give a higher input 1, output 1 will show the voltage that is connected here. If you give a higher input 2, output 2 will show the voltage that's 0. That's it. Did you get that?
Yes.
Yeah, cool. Okay, let's proceed. So now let's see what the circuit diagram is. This is a circuit diagram. Let's see this properly and understand how it gives the right functionality. So in this experiment, we are only using one 9-volt battery because we want to simplify the circuit. But don't worry, it will still work. One 9-volt battery will still be enough to drive 2 motors because we'll not be using 2 motors all the time because it needs to even turn, right? What needs to turn. Okay. And this is a 5-volt voltage regulator. Okay, let's see how this works. It basically has 3 pins, and one of them is ground. One of them is ground. Input. There's 2 input pins. I mean, one input pin and one output pin. Okay. So the input pin should be connected to whatever voltage you have. It could be any voltage. It could be a little fluctuating voltage also. If you connect it to input 1 and ground the output pin, it will give you an almost steady output of 5 volts. That's the basic functioning of a 5-volt voltage regulator. So when you see the voltage regulator, I guess you will see the markings over here, which pin is what. So see that properly and connect input to the right thing. Okay. And so basically 5-volt regulator's input is connected to the 9 volts high, and output is taken from here and connected to the breadboard's pluses. And this column of the breadboard, the plus column, is connected to the plus column of this. So you can take power from any column over here or any column over here. Okay, I guess that's clear. Now let's see the circuit of L293. So as we saw, this was enable 1, right? So that's a high, that's connected to high, and this is the other enable. This was the other enable. This is also high. So enables are done. Next, this was the VCC, that is also high, and the other VCC2 should be connected to 9 volts because that's what we need to supply to the motors. And the ground pins are okay. All these 4 pins, ground, 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 ground. All the 4 pins are grounded. Next, what about the input pins? That's the key aspect over here, and that's what you need to understand. So one of the inputs will always be a ground. So what does that mean? What will be the if input 1 is always grounded, what will be output 1? Anyone?
0.
Yeah. So one of the outputs will always be 0 because one of the terminal of the motor will always be 0 and will be controlling the other terminal to make it on or off. Okay, hope that's clear. Any doubts over here? Okay, let's proceed. So one of the terminal will always be grounded. Let's see the other terminal. The other terminal's input 2 is connected to the output of IR sensor. Here is where we'll be using the data which we receive from IR sensor and accordingly controlling the motor. So let's say if the input of the IR sensor is high. So what will be this thing? What will be the voltage over here?
9 volts.
9
Yeah,
volts.
so that will mean the motor will start turning. So if you give a high to this terminal, I mean, from this sensor, this will start turning, and the same thing is on the left also. Hope that's clear. So as I mentioned before, now let me ask you a key question over here. As I mentioned before, the background is white, and you have a black line on it. Think over this properly. So you have a white background, and you have a black line. Now, I'll also give you another hint that the thing is, the black line is broad enough such that both the IR sensors which are connected to the board will always be on the line. So what will happen when both the IR sensor will be on the black line? What will they output? Anyone?
Both will output high and both the motors will rotate.
Yeah, exactly. So when both the IR sensors are on the black line, both motors will be running and it will be going forward. Now let's say you have a right turn. What will happen?
Left
One,
motor
one
will
of them will
stop.
stop detecting.
Yeah, let me give you some more information also. Like when there's a right turn, you have two sensors, a right sensor and a left sensor. Which sensor will start outputting what? I mean, when it's taking a turn, what will the right sensor output? When it's taking a right turn, what will right sensor output?
High.
Low. Low.
What is
0.
What about the left sensor when it's taking a right turn?
High.
High.
Left sensor should output a low, right? Because it will encounter white. Is everyone clear with this? Like if there is a right turn and
Yes.
you have a right sensor and a left sensor. So the right sensor will always be on the black line. So it will always be outputting high. So momentarily what will happen, the left sensor will just, encounter white. So it will go low. Is it clear?
But then the motor will turn in the left direction.
Yeah, I didn't tell you. I didn't tell you yet which is the
We can
right
just-
sensor over here and which is the left sensor connected to the board, right? We'll get to that point later. I'm just telling you. On the board, you're having two sensors. One is a right sensor and one is a left sensor. Forget about the motors for now. Just tell me what will happen when the board is taking a right turn. What will right sensor output and what will left sensor output?
Right sensor is high, left sensor is low.
High, left
Exactly.
low.
And what should be the motors? Which motor should be high and which motor should be low? Right motor and left motor. When it's taking a right turn.
The right motor should be low and left motor should be high.
Yes. So I guess you are getting the interchange which should happen over here, right? So if the right motor should be controlled by the left sensor. I mean, not in this way. I mean, you need to attach this sensor to the left in the left front. I mean, we'll show you where to connect each and every motor in the live demo. But this should be in the left, and this should be in the right on the board. Is that clear?
Yes.
Yeah, cool. So at this point, any doubts with the circuit diagram?
Why do we 9 volts on one side and 5 volts on the other side?
Yeah, okay. So the functioning of an N293D is that way. So one pin, which was VCC1, is used to power the L293D. If you are powering the L293D, it should be 5 volts, right? Is that clear? Power to L293D is the L293D is designed in such a way that its power should be at 5 volts. Okay, so VCC1 will be at 5 volts. What about VCC2? Functioning of VCC2 is such a way that whatever voltage you give at VCC2 will be given at the output terminals. So you need 9 volts on the motor, right? So that is the reason why you connect 9 volts here.
Yes.
Got it? Okay. Fine. So any more doubts? Okay, let's proceed. So now let's see which I just described over here using some diagrams so that you understand the drive mechanism. So for going straight, what should happen? Both IR outputs will be 1, so both the motors will be going. Should be going, actually, that's our plan. When it's going straight, both the IR sensors should output 1 and the motor should be going and it should move forward. That's our plan. Based on that, we'll see how to place these IR sensors. Fine. Next, let's see. What about turning? So this diagram gives you a visualization of when it's turning left. This should be a slower one. In our case, we are just making it 0, such that to simplify the circuit. And when it's turning left, this should be high. This should be going, and this should not be going. And when it's turning right, this should be at a high speed, and this should be at a low speed. And that's what is written over here. You can just go through this once and get an idea of what's happening, and if you have any doubts at the end, we'll see. Just take a minute, think through it. Okay, if there are no doubts, let's proceed. Now we'll give you a live demo from here and make a few test runs. Let's see how it works, and we'll debug it together. Okay. You can just take a screenshot. One of you can, if you can, just take a screenshot of this and share it in the chat, so that it will be useful for you guys while making it. After posting it, just confirm, or we can proceed.
Done, sir.
Yeah, okay. Now let's go to the live demo. Okay, cool. So here is the board which we have in our lab. So we have these two IR sensors over here. So we use double tape. So you can use Fevicol also if you want. Just you need to attach it over here. So these two IR sensors, you need to make a lot of trial and error in making a placement, and accordingly just come up with this. And here is the caster wheel which we gave in the pressure skate. So connected there, and this is the connection. Here is the 5-volt voltage regulator. So it's a bit messy, using all the jumper wires and fine. And just look into how to connect these motors. Okay, that's the key point. Like, so these wheels actually have screws over here. So you need to just plug in the wheel and tighten this. And you need to put the motor from this side and tighten this screw also. Okay. And this is the board. And I think you can all start making the boards now. So if you have any doubts at this point, just start making the boards. And in a few minutes, we'll give you a live demo of how it works. We'll see. So the ones who don't have Freshers Kit are encouraged to try a simulation. So if you're interested, if you complete the simulation, you can maybe present it later. We'll see. The others, you're encouraged to turn on your cameras and do it. Start doing it. In a few minutes, we'll show you how it works. We'll see.
Could you explain the working principle of IR sensor?
Okay, so IR sensor, uh, I think you can Google it first of all, or let me just explain you in brief. So what happens is there's an IR transmitter. So the power which you give to the IR sensor is somehow routed to the power of the IR transmitter, and IR transmitter is always on somehow. And whatever there's a photodiode. Basically, a photodiode has its own working principles. Like whenever it detects, it's basically an NPN diode. Sorry, I guess it's not. It's some kind of diode, just a PN diode, and when it detects the IR radiation, it reacts in a particular way, and you get a high or low in the circuit. And that there's a comparator circuit over there. So what happens is, based on the output which is being given by the receiver, you can tune the output which you get. So let's say you are tuning the potentiometer in such a way, then what will happen is, for one particular value of the potentiometer, if uh, if you are receiving a particular strength of radiation, let's say X, then you might get a high. But if you tune the potentiometer in such a way, in some other way, then for the same IR radiation, you can get a low. So it all depends on the comparator circuit which you have in there, and based on the environment you are in, you need to set the potentiometer in that way. But in the IR sensor which we have in our lab, in which we provided you, is pretty good. I mean, works in the indoor environments.
But why does it give a low for a white surface?
Hmm, like, do you expect a high? Why do you expect a high? When it
Because
depends on internal.
white surface will reflect the maximum of light, right? So
Yeah.
compared to the black surface, more amount of light is falling on the receiver.
Hmm. So, but that doesn't guarantee the output, right? I mean, the internal circuit will guarantee it, and the internal circuit is designed in that way.
Yeah, so I think I can answer you. Actually, what we receive from the IR receiver, that signal is generally very weak. So like that is processed through a integrated circuit, and also we input the potentiometer signal to that integrated circuit in order to like change our amplitudes. And like I would say this, that what the IR sensor receives isn't readable by other circuits, but when we input that signal to the integrated circuit and what it outputs, then that is readable. And I can tell you that that you could buy both type of receivers, those that output high on white and those that output low on white.
Yeah, like basically the receiver is an analog circuit, right? I mean, it will give you a range of voltages. I mean, the output which you get from a receiver can be a range of voltages from 0 to 5. And basically, there is something called an op amp. If you're familiar with it, it will be very simple to understand the circuit. Basically, if for that analog output which you're getting from the receiver, if you set the potentiometer in such a way, then it will be a high. I mean, the output of the sensor will always be high or low. So the internal circuit should decide based on should I output high for this signal. So that will decide it.
Okay, that is what I wanted to know. Basically, there exist two, I mean, these types of IR sensors where white surface results in high and white surface results in low.
Yeah, it could be. Yeah, and it depends on this internal circuitry. Then.
Okay.
I have a question. What does the VSS1 do?
Can you repeat this?
What is the function of VSS1?
Can you help me? I can't see the chat, and like some people also.
I also can't see the chat.
Yeah. Okay. Yeah, we liquidated. What's the doubt?
Can you describe the function of VSS1?
I think you mean BCC1, right? So that's basically
I tried to search for it, but somebody said it was written as VSS, so I got confused.
Oh, okay. Yeah, I don't know. It might be some other kind of nomenclature, but usually it's VCC1, and basically L293D needs a high 5 volts at VCC1 to function properly. Like whatever functionality you are seeing, not just see that functionality. You need a 5 volts at VCC1 and a ground and a 0 at ground. Usually many integrated circuits usually have, I mean, almost all of them have VCC and a ground. Might be familiar with that. So you need to give a higher VCC and a lower ground. Did it clarify that or was that your doubt? Or anything else?
Yes, that was my doubt, but I wanted more detail about it.
So I can explain it.
You mean like which detail? I mean, why do you give a 5 volts high, right?
Yes, why do we give a 5 volt?
Okay. So the thing is, final internal circuitry is based on transistors. I mean, okay, it's usually NPN transistors. And are you familiar with that? How does a transistor work?
Yes, I know some things about it because we had to study that.
Okay, so then you might be knowing, like for each functioning of a transistor, let's say an NPN transistor, it has 3 terminals. Let's say on the top you have the emitter, on the bottom you have the collector, and a base at the left. So for it to function, you need to give a high at the collector, right? At the collector, you need to give a high, and if you control the voltage at the base, you can control the current through the transistor. Like now, let's say we have transistor. We have
So
base
it's the first voltage we give between the base and the collector so that the current is significant.
between the collector and the emitter, usually.
Yes,
When the
that.
emitter is connected to the ground, and at the collector you give a voltage. And based on the, I mean, this is a very basic circuit. I mean, at the base, this is a basic building block. You can connect many transistors and create logic which you want. So at the grassroots level, for one transistor to work, you need to connect the high to collector, and emitter should be grounded. And based on the voltage which you give at the base, you can control the current, which is flowing. Got that?
Yes, I got that. Thank you.
Yeah. Okay, now let's have a test run and see how it works and debug together. Okay, let's go. So yeah, here we have the line follower bot. Can you turn the camera? Is it possible? Yeah. Yeah. So the thing is, you need to debug a lot to find the right placement of the IR sensor. Okay. And you can see how it's working on an internal feedback mechanism and turning properly. Okay, so that was it. You guys can also try now and see how much you can do it. We have another arena also, which we'll show you at the end. For now, we'll just start building your balls. So the ones who are trying out bots, you can just feel free to turn on your cams and show us what you're doing. We'll help you at any point. So yeah, we have another arena here. Let's see.
First, we have to build the circuit, right?
What? Yeah. Yeah, that's it. Yeah, any one of you, if you're working on a circuit, if you want to show anything, feel free to show, and Also, if you have any doubts, practical doubts, you may ask.
I had a doubt like, how did you connect the IR sensor to the breadboard exactly?
You mean the connection, or how did you
Yeah,
connect?
मतलब, how should I connect the terminals with what wire? मतलब,
Okay, so there's a jump. You'll get jump. You have jumper wires, right?
yeah, yeah.
Yeah, like you'll have a female jumper wire just connected to the sensor. I mean, you have something called a female to male jumper wires. So you need to use those.
Yeah, but like I used that female one, but the
Hmm.
connection seems loose, so I thought something else was.
Acha, connection is loose. Yeah, you have many wires, right? Let's see.
Okay, okay, I'll try.
See, when you connect that wire, yeah, you'll have to press it tightly, and then this click sound comes, so you know that it's properly connected.
And, so anyone who has done the circuit, you can feel free to turn on your camera. Or anyone who has started, you can just tell us what's the progress.
Hello. Hello.
Yeah, hello.
Yeah, I wanted to ask that can I use a DC adapter? I currently don't have a battery. It's rated 9 volt and
Okay.
800 milliampere.
You can use a DC adapter, but just see the rating. I mean, it should be around 12 volts is okay.
Yeah, it is written 4 to 12 volts and 800 milliampere.
Yeah, it will work. Yeah.
Thank you.
But you need to, go with the board using, the wire and all.
Yeah, I have cutted it. I have two plus
Hmm.
and minus.
Okay.
Hello, Prashant. Yeah, hello, Prashant. So there is an announcement we wanted to make. All right. So soon, Technology Robotics Society will bring you Winter School of AI and Robotics. So this event is held during your vacations and it is held in the weekend. So there will be a series of lectures which will be held for you guys on various verticals or different domains during the weekend, Saturdays and Sundays. We conduct this event with, in association with IEEE. It are conducted in your vacations, so you are free enough. And so winter school sessions, just like this session will be very interactive, as the people teaching you will be second years, and they will interact with you, and you can ask lot of different doubts. The concept we cleared in the create sessions will also be explained in detail, and every part of it can be discussed. The perks after you complete this winter workshop, you will get a certificate from IEEE, and also winter school serves as a good starting point for the registrations and in the selections of various research groups. Soon we will post about it in detail in our Facebook and other social media, in our other social media platforms. So I would like to mention that one of the verticals or even various verticals would require Arduino, and thus it is highly recommended that you either have the component with you or buy the freshers kit, as there is still some time before the winter workshop starts. It is really good if you have the components with you so that you can work with the mentors, what they're explaining, you can do it together with them. So go on to our Facebook page or any other social media platform you find feasible and check out the special kit post once again. And if you want it, you can still register for it. Form is still open. All right. So now we will be ending with this hackathon if none of you have anything to discuss. Hope you got an idea of what we can do with these various components. We didn't use Arduino yet, but in the winter workshop, we can see the Arduino and a lot of different type of bots. We will go into depth. And so yeah, so you can see the chat as well. We have provided the link for the registration form for the winter for the freshers kit. The entire bot we showed in which was running on the arena was made using the freshers kit only. Yeah, so that's it. If any one of you has any doubt, no, then we will be ending the meet. All right, that is clear. Okay, so as it seems that none of you have doubt, I hope you like the session. You got the feel of it. Have a really good day. You can leave the meet now. Good night.
Excuse me,
Yeah.
I had a doubt.
Um, yeah.
Uh, I had set my enable 3 4 and input 3 pin too high. That is given both of them 5 volt. So and I checked the voltage across the output 3 and the ground. So I wasn't getting any voltage there. That is, I was getting 0 volts. So um, is what can I do for that?
What was the question? Can you please repeat it? You weren't
I
audible.
had given my and 5 volts manually. So and I was getting 0 volts across the output 3 and ground. So
You are
does
getting
that
0
happen?
across. You are getting 0 across, output 3 and ground. In which case?
Having said